Hi, my name is Chris Schaffer, and I'm part of the group that is working on the Stanford car image dataset. And this is just my brief summary of what I've done this past week for our status check part one. So this past week, I explored several different types of architectures, all related to convolutional neural networks. Um, this involved a lot of parameter tweaking, combining different layers and different pooling techniques. Um, and yeah, I learned a lot in this process already. So we found that we might not have enough data as it is to make accurate or at least satisfactory predictions, classifications, sorry. The models overfit a little too easily and a little too early, so we never really achieve high accuracy with a good amount of reliability and utility. And so data and image augmentation have been really helpful for that because it kind of expands the space that you're allowed to explore with these models, and it usually gives better results and reduces overfitting as well. So to recap, our data set has about 16,000 images as it stands, with no augmentation or anything like that. They were originally labeled um, each as a unique class, and a class was defined as the combination of make and model. There were 186 models after pre-processing and some data editing. And so, since that's a little unruly, I tried making CNNs that could classify based on a large class set, like the make and model set with 186 classes, sort of a medium-sized set where I just looked at the make and see if we could classify that, and then the type. So something simple like sedan or van or SUV. So this is one of the better CNNs that I got working for the make and model classification process. It's very large, it's very unwieldy, and it takes forever to train. Also, you can see there on the right, it overfits pretty early on with an accuracy of around 20%. So that's not ideal. So um, there could be a lot of reasons this is overfitting, and we still have to discover what exactly those reasons are. So this was sort of promising, building a classifier to classify the make only of a vehicle. There are only 49 classes, so automatically that's an easier problem, and it results in a less complex model being needed for it. So I'm still working on training this model. It takes quite a long time to do this. This is after 100 epochs, but clearly we can still train it a bit before we see any overfitting, so that could be promising. And the last CNN I tried making was one that could classify type. This was sort of a set of information that I generated myself, so I wasn't really sure how much it would work. We got some decent accuracy though. There are 5 classes, and the accuracy was about 65%. And yeah, we had the same overfitting problem there too. So overall, data augmentation and some other fancy techniques could help reduce the overfitting. So next steps for this coming week, determine the most feasible data for modeling to ultimately classify and identify a vehicle from an image. Explore using a combination or an ensemble of convolutional neural networks. Maybe that'll help, or maybe a multi-model approach might. Address the overfitting, like I've been saying, and keep performing more data slash image augmentation, because that seems to really boost our results in training time. All right. Thank you for your time.